Calculate the pH of aqueous solution of 0.0003 molar hydrogen ions. Before we start, you might want to know why pOH calculations. With our various definitions trying to classify things into acidic, basic, and neutral. Let's say we are given a substance, and you say that substance is neutral or that substance is acidic. How acidic is the substance or how basic is the substance? So pH is all about finding the numeric value of the acidity or basicity of a substance. Let's say if I say solution A is acidic, I should be able to say, let's say it is a 2.1 molar acidic, right? Or let's say if I say solution B is acidic, I should be able to give a value, let's say 0.5 molar acidic. And you see the value is going to tell me how strong or how concentrated the acid or the base is. So there is a need for us to be able to provide numeric value for acidic substances, basic or if neutral, a neutral substance is just a neutral substance. So that is the reason why we want to learn the calculations of pH and pOH. And it is very important because with a given solution and each concentration numbered on it, let's say solution C is a basic solution, but it is, let's say, 8.5 basic, then I know, oh, this is how solution C is. Without the numeric value indicating how acidic or basic it is, it kind of look like something different. Well, and the pH scale ranges from 0 to 40 with a midpoint of 7, which is neutral. So substances from 0, as we move forward to 14, acidity increases, acidity decreases, and basicity increases. Basicity increases. So substances from 1, 2, 3, 4, 5 to 6 are more likely to be acidic, with 0 being the strongest, followed by 2, 3 in terms of acid. And as they move towards 8, 9, 10, 11, 12, they become more basic. Now, one basic test that you want to know is how to test for, to test and see whether a substance is an acid or base. If I have blue litmus paper, and I put it in a solution, and at the end of the day, the blue litmus paper turns red, it means my substance is acidic. It's acidic in nature. But if I have a red litmus paper, the opposite, and I dipped it in a solution, and at the end of the day, the result is a blue litmus paper, that means the substance is basic. So that is what you might want to know. Now let's look at the various formulas that we use to calculate the pH or pOH of a given substance. pH is equal to negative log of the hydrogen ion to the base 10. And then pOH is also equal to negative log of the OH ions, to the base 10. So these are the two basic formulas that you need to know. And what if you want to calculate the H plus ion concentration alone? So H plus ion concentration, the hydrogen ion concentration, is equal to 10 to the power, since we are talking about hydrogen ion, negative pH. And the OH ion concentration the OH ion concentration equal 10 to the power, since we are talking about OH, which is pOH, so negative pOH ion concentration. So you need to know these formulas to be able to do pH, pOH, and then pOH calculations. So write them down and notice them very well. Another formula, let's name this one, 2, 3, 4. So the fifth formula is pH plus pOH should give you 14. So take note of these formulas very well. And this formula holds at a temperature of 25 degrees Celsius. 25 degrees Celsius. So if in the question 25 degrees Celsius is indicated, then it means you can apply this formula. But generally, you can apply this formula. This formula is from the auto ionization of water. The auto ionization of water, we know that represented by Kw. Water ionizes, water itself ionizes into OH minus and then H plus. So, and it has a value of 10 to the power negative 14 moles per dm to the power 6. You don't have to worry about this, but you just have to know that from the auto ionization of water, if we are to calculate for pKw, this value here is pKw. This the value is Kw, which is 10 to the power negative 10 moles per dm to the power 6. If we are to calculate for pK, the value of Kw, the value of Kw, just take pKw equal negative log to of Kw to the base 10, which is equal to negative log of 10 to the power minus 14 to the base 10. This gives us 14. And this 14 is a value of both H plus ion and OH plus ion. So which means that the pOH ion plus pH, the pOH plus pH, it should give us 14, right? So that is where this formula is coming from. So you need to know that too. So now that we are done with the formulas, let's try to solve our problems now. Now to our question. This question is asking us to calculate the pH of the solution of hydrogen ion concentration of 0.0003 molar. Now we are looking at pH and it is hydrogen ion concentration that we are looking at. And we know that pH is equal to negative log of hydrogen ion concentration to the base 10. And what is our hydrogen ion concentration here? Negative log to the base 10, 0.0003. Now you want to point this on your calculator. On your calculator, we have this log here, which is generally to the base 10. Anytime you are pointing a log to the base 10, just point to this one. If you want to give it a base aside base 10, then you can use this one. But in this case, we are looking at log to the base 10. So minus log to the base 10. In this case, we don't have to bring the 10 again. This is also log. It is already log in the base 10 already. So 0.0003. Then you close your bracket. Then you click on equal to. So this gives us a value of 3.522. But since the number next to it is more than 5, we'll round it to 3. So that is a pH for this problem, the hydrogen ion concentration for this problem. The pH of a solution is 2.87. Calculate the hydrogen ion concentration. In this case, we have been given the pH to be equal to 2.87, and we have to calculate the hydrogen ion concentration. And we know that pH is equal to negative log of hydrogen ion to the base 10. All right. You can just write the log without indicating the base. Once you don't indicate the base, it means it's to the base 10. But it is good to indicate the base when you are writing. And we said from this formula, we have to calculate for the hydrogen ion concentration. That is what the question is asking us to do. And we also said that if you want to calculate for the hydrogen ion concentration, the hydrogen ion concentration, since we are talking about hydrogen ion, should be equal to 10 to the power negative pH. Right. So keep these formulas in mind. You can be calculating for the pH or the hydrogen ion concentration, or the OH concentration or pOH. So try to link those two formulas. So pH or hydrogen ion concentration, or pOH or OH minus ion concentration. So try to link those formulas. So now we have to calculate for the hydrogen ion concentration, and the hydrogen ion concentration equal 10 to the power negative pH. But we've been given the value for the pH, so just go ahead, 10 to the power negative 2.87. 2.87. So now you can use your calculator. 10 to the power negative 2.87, 2.87, and this gives you 1.389. So 1.3896, so we can just 489. So we can just round it to 9. So that is it for this problem. Calculate the hydroxide ion concentration at 25 degrees Celsius in a solution whose pH is 5.78. Given that the auto ionization of water Kw equal 10 to the power negative 14 mole squared per dm to the power 6. Now notice the question very well. We are calculating the hydroxide ion concentration, which means this is what we are calculating for, the hydroxide ion concentration, not pOH, but hydroxide ion concentration. But the question has given us all the necessary things that we need to be able to calculate. First of all, at 25 degrees Celsius, and we've been given the auto ionization of water. And we know that pH plus pOH equal 14. So the same thing as the hydrogen ion concentration multiplying the hydroxide ion concentration equal 10 to the power, equal Kw, right? And Kw is the same as 10 to the power minus 14. So the hydrogen ion concentration multiplying the OH ion concentration should be equal to 10 to the power negative 14. So it means if we know the concentration of one of these, we will be able to calculate for the other one. And now we've been given pH, not the hydrogen, not the H plus ion concentration, but pH. So we can calculate for H plus concentration and then come and substitute it into this formula to solve for OH ion concentration. Let's do that, dividing both sides of the equation by, okay, let's solve for the H plus ion concentration. We've been given pH to be equal to 5.78, and we know for H plus ion concentration is going to be 10 to the power negative pH, and this is going to be 10 to the power negative 5.78, 5.78. And let's put this on the calculator. 10 to the power negative 5.78 gives us 1.66 1.66 10 to the power negative 6. Sorry, 10 to the power negative 6. 1.68 times 10 to the power negative 6 molar or mole per dm cube. So the H plus ion concentration equal 1.66 mole. I'm sorry. H plus ion concentration equal 1.66 multiplied by 10 to the power negative 6 mole. I mean mole per dm cube. So now, after substituting the value of the H plus ion concentration, which is here, then we've gotten to, the OH minus concentration to be 2.25 multiplied by 10 to the power negative 9 mole per dm cube. So that is the concentration of the hydroxide ion at 25 degrees. The concentration of H3O plus ion in aqueous solution of HCl is 0.025 mole per dm cube. Calculate the pH and pOH of the solution. So in this case, we've been given the acid, right? So anytime the acid is given, it is important to write a balanced equation for that acid. That in aqueous solution means that the acid plus water, and then HCl plus water will give us the H3O plus ion plus the Cl minus ion. Writing a balanced chemical equation. So let's say we have 3 of hydrogens here. We have 1, 2, 3 of hydrogens there. We have 1 chlorine here, 1 chlorine there. We have 1 oxygen here, 1 oxygen there. So we are good to go. So the H3O plus ion concentration was given out to be 0.025 mole per dm cube, or you can just represent it as by molar, capital M. Now we have to calculate for the pH and the pOH concentration. The H3O plus and the H plus ion, they are responsible for the acidity of a substance generally. So pH is written in terms of negative log of of H plus ion, which is the same as negative log base 10 of H3O plus ion concentration. So here we are dealing with H3O plus ion concentration. So we are calculating pH equal negative log of H3O plus ion concentration. And the H3O plus ion was given us to be 0.025 molar. So minus log to the base 10, 0.025 molar. Punching this on the calculator gives us 1.602. So that is the pH of the solution. So now we have to also calculate for the pOH of the solution. And we know that pH plus pOH equal 14. pH plus pOH equal 14. We know our pH here, which is 602. So let's make pOH the subject. So crossing, let's pH cross the equation sign. It becomes 14 minus, since pH is positive, crossing become minus pH. So we know our pH value to be 1.602. So on your calculator, 14 minus 1.602 gives us 12.040. So that is the pH of the solution. So in summary, the pH of the solution is 1.602 and the pOH of the solution is 12.40. calculate the pH of 0.1 molar H2SO4 solution. So with this problem, we have to write a balanced chemical equation. H2SO4 will break to give us H plus ion, and then SO4, 2 minus ion. Let's see whether the equation is balanced. We have one S here, 4 oxygen here, 4 oxygen there. And then we have one hydrogen here, 2 hydrogens here. We just have to add 2 here. So 2 hydrogens there, 2 hydrogens here. So the equation is now balanced. So we've been given the concentration of the H2SO4 to be 0.1. It means in this case, the H plus ion is responsible for the concentration. We have 2 mole of H plus ion here. So the concentration of H plus ion is going to be 2 multiplied by 0.1. So then 2 multiplied by 0.1, what do we get? That is 0.2 molar. We are calculating for acidity, and the H plus ion is what is responsible for the acidity, or the H3O plus H3O plus ion. So if the mole is increased, it also have to affect the concentration given to us. So now pH is equal to negative log to the base 10 of the H plus ion concentration. I've known our H plus ion concentration to be 0.2. So this is going to give us negative log to the base 10 into bracket 0.2. So operating that gives us 0.7. So the pH of this solution is 0.7. Calculate the number of OH ions present in 250 cm cube of solution whose pH is equal to 3. The Avogadro number is given to us to be 6.023 multiplied by 10 to the power 23 per mole. The question is asking us to calculate the number of OH ions. For us to be able to calculate the number of OH ions, we have to know the OH minus concentration. But we have not been given that, but we've been given a certain volume here and a pH here. But we do know the relation between pH and pOH. So we can calculate, or we do also know the relation between H plus ion and then OH minus ion. So that's the relation between H plus ion and then OH minus ion concentration. But from the pH, we can calculate the H plus ion concentration. We know that pH equals negative log of H plus ion concentration to the base 10. And the H plus ion concentration is equal to 10 to the power negative pH. So we'll be given pH. So this is going to give us 10 to the power negative 3. So 10 to the power negative 3 is going to give us 1 by 10 to the power negative 3 molar. That is the concentration of the H plus ion. So now that we know the concentration of H plus ion, let's solve this equation. So if we divide both sides by H plus ion here, this is going to take care of that. So the OH minus ion is going to give us 10 to the power negative 14, all divided by H plus ion concentration. We have to calculate the number of OH ions. But before that, we need to know what exactly the OH ion is. So this is going to give us 10 to the power negative 14, all divided by 1 times 10 to the power negative 3. So that is the H plus ion concentration, which we calculated here to be. So simplifying this is going to give us 10 to the power, 1 times 10 to the power, we point it on your calculator, negative 11. So now we know that this is our OH ion concentration. So our OH minus ion concentration equal 1 by 10 to the power negative 11. But a question said we should calculate the number of OH ions. So number of OH ions, which is number of OH ions or number of any entity, equal to the mole of that entity multiplied by the Avogadro number. But in this case, we've been given the Avogadro number. So we need to calculate the mole of OH ions. So to calculate the mole of OH ions, we know the concentration of OH ions and we also know the volume given to us. And concentration is equal to mole over volume. So if we simplify this, mole will be equal to concentration multiplied by volume. But we have to convert our volume to dm cube. So we know concentration to be 1 by 10 to the power. So 1 by 10 to the power negative 11. And the volume is 250. So we just divide that by 100 in order to convert it to dm cube. Sorry, by 1000. 1, 2, 3. So this is going to be multiplied by 0.25 dm cube. So simplifying this is going to give us 2.5 multiplied by 10 to the power minus 12 moles. Now that we know the moles of the OH ions, the OH minus ion, we can go ahead and calculate for the number of OH ions. So number of OH ions equal to the moles, which is 2.5 multiplied by 10 to the power minus 12 multiplied by the Avogadro number, which was given out to be 6.023 multiplied by, I'm going to write it here, multiplied by 10 to the power 23 mole. So simplifying this is going to give us the number of OH ion to be 1.50 6 10 to the power negative 34 OH ions. So that is it for this problem. Feel free to check part 2 of this video, and you can also check my playlist on acid-base calculations. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.